Alright, so this is 4.2, Graphing Polynomials. This is part 2. We were talking about where we have figured out what our shape of our function is going to be, and we talked about multiplicity, and we talked about the degree and kind of how those things are going to behave depending on what the a value is. But there's another way to go about solving this problem. If you want to figure out what the shape of the graph is, you can figure it out using this method. Okay, so we found out our first 0 is at 0, 0, right? So there's my 0, 0. And I'm going to go ahead and use a different color so it's real clear that I'm kind of making this separate. So here's our first section. We have negative infinity to 0. And then we have from 0 to 3 halves. And then I have from 3 halves to positive infinity. Okay, so now I've got this broken into 3 separate values. What I'm going to do is I'm going to pick a point in each of those groupings, each of those intervals, and I'm going to find out whether or not it's positive or negative. Now, if it's positive, if I find out the answer is a positive value, then that answer, everything in that category is going to be negative or positive. It's going to match what it is what that you found. So if it's positive, the whole interval is positive. If it's negative, then the whole interval is negative. And when I say negative, it means it's below the x-axis, and positive is going to be above the x-axis. So the big key here is don't pick somewhere that is a 0. So we cannot pick a 0, and we cannot pick 3 halves. Those two will give us a real 0, and that's not what we want. Okay, so we have, I've picked some numbers here, and I picked a -1, a 1, right? That's going to give us that middle interval, and then 2. That's going to give us our final interval. So we're literally just going to plug it into our original function, right? So our original function, if we want to quick take a look, is we had that x cubed and 2x, negative 2x plus 3. So that I can actually write that as, let me go ahead and write it as negative 2x to the 4th plus 3x cubed. Alright, and now what I'm going to do is I'm literally just plugging these values in. So I have a -1, so I'm going to have a -2, -1 to the 4th, plus 3 times my -1 to the 3rd. And when you go ahead and do this, you wind up with a negative value. It's going to wind up being a -5. So I have an ordered pair of -1, 5, -5, I mean. Alright, so this is going to be a negative value, right? So I can I'm going to have this part down here. It's a negative value, and I'm going to have my point of 0, 0. Oops, I don't want to do that. Let me go ahead and erase that, and then I'm going to go ahead and, alright, so then it's 0, 0. So I'm just kind of making a list of all the points that I'm picking. Now I'm going to pick a 1, and then we go ahead and do that. We do the 1 in place. We've got a -2 times 1 to the 4th plus 3 times 1 to the 3rd. That's going to get me a positive value. It's going to get me a +1. And let me just go back and say here, this was a -5. Alright, so I have my 1. I'm going to wind up with a +1. So I have a 1, 1. So for this interval, it's above my x-axis, which means the whole thing, this whole interval is positive. It's all above the x-axis. And I'm going to do the same thing with my 2. Actually, let me go ahead and mark down my 3/2 and 0. And now I'm going to pick a 2, and then we're going to find out what happens here. When I take my -2 times 2 to the 4th plus 3 times 2 to the 3rd, and that's going to get me a -8. So my ordered pair here is going to be a -8. All right. So we've gone ahead, that's because that's negative. This section is going to be negative as well. All right. So this is very similar. I mean, we basically have the same information that we would have had using our degree and multiplicity and all of that, but we were able to do it with just using, we found our zeros, and then we were able to pick a number in between those zeros on those intervals and determine how it was going to behave. All right. So one thing that you want to note, if we're going to have to graph this, right, if we were to graph this, we would want to pick these values for sure. We already know what they are. And then you're going to want to pick another point or two, probably 2 points in here to figure out what's happening in the middle. Remember, the middle piece is where all of the stuff is happening, right? And when I say stuff, I mean when we have like a wiggle in our the quadratic overarching formula or form, and where you would have the wiggle of the cubic, where you'd have something, you know, kind of bend and then come back up again. So this would be where you'd want to look, the center piece. Okay. So the additional points, right, you can use those. Page 237, if you are interested, you can go back and take a look at the steps on this. Assuming that this did not cover it enough for you, you can go back to page 237, and it gives you the same information, gives a good summary of the steps. All right, so we've got this, what's called an intermediate value theorem, and actually let's go ahead and I'm going to wind this up, and we'll pick up with our intermediate value theorem on part 3. Okay?